My friend Lajos from Modception, yesterday he scanned a car chassis, which is, the result is pretty good. And he is also going to share the result with you guys, the scan and the CAD. So, and he put all the sections together with a tolerance of 0.25 millimeters, a quarter millimeter, which is really great. So, and this raises a question you might be interested in how accurate Trackit is. And you see in the product page that we say is 0.025 millimeter plus 0.04 times the length. So here is what I'm gonna do to test it today. This thing is called a ball bar. This normally is widely used in the metrology annihilation, and of course this is also freshly calibrated by this morning. And the result is 999.5713 millimeters, really precise, 4 digits. Okay, so, and this was freshly calibrated by a CMM machine. If you don't know what it is, CMM stands for the coordinate measuring machine. So what our plan is to scan this bar, this ball bar with Trackit in the 3 coordinates, which is X and Y and Z, and we will compare the difference between in the geometric wrap and also with what exactly here calibrated. Okay, so scan number 1, let's go. First, let me set the target point distance to minimum because I want the best detail and accuracy. Okay, let's just work on the 2 balls here because that distance I mentioned that is calibrated is the distance between the 2 center of these balls. So here we go. Okay. So after fuse this, I'm just gonna export the point cloud and try to compare and try to calculate the distance and compare with the real distance here. Okay, with a little cleaning, do a overlap. And we don't need to do the meshing, we just export the point cloud for the measurement and that'll do. So I'll just call it number 1. Okay. Then this is the software I'm gonna use. It's called Geometric Wrap. Pretty familiar software with you guys if you are in the 3D industry, widely used in the measurement. Okay. Okay, so what I'm gonna do now is in this software, I'm gonna try to find think it's under feature. Find the center of the two balls. So I think it's the sphere. Number 1, apply. Next. Wait, where's my, okay. Okay, and number 2, apply, point 2. Okay. So now just to find out the distance between the two centers, the 2 points, so measure from feature, so point 2, and point 1. I think I have to go back to feature. Huh? What the heck? Wait, so I have to manually click to the point 2, I think. Okay, done. So what I got is 999.55283. So let me open up the calculator. So this is what I got, 999.55283 minus what I have here, 999.5713. Okay, I'll try to remember that number. 713, which equals to 0.018457. Let's consider as 0.019, which of course meet the requirement because this 1 meter long ball bar we have is, we claim is 0.025 plus the volumetric accuracy is 0.04 times length. The length is 1 meter. I mean, we're not going to use that 999 one, so just consider it's 1 meter, 0.04, which is, of course, it meets the requirements in the x-axis. Okay, so step 2, now we try to scan it in the axis y and compare it again. And finally, we're going to compare the medium average number of the 3 results. Okay, scan number 2, the y-axis. Okay. Could you adjust my tracker? Okay. Okay, cool. Thank you. Okay. So now let me scan it in the y-axis. Again, same thing. Let me put it at 0.15 millimeters. Okay, scan number 2. I missed a little part here, but that's fine. Okay, fuse it. Let's set the same 0.30 millimeters distance. Okay, now I'm gonna name it number 2. And again, geometric wrap. Now open number 2. All right, same thing. Find the sphere, find the center here. Okay, it's number 1. Okay, number 2. Feature 1 and feature 2. Oh God, I wonder how do I just measure between the 2 features. Okay, anyway, I got 999.610357. Okay. Okay, what's the difference between that is, let me do the math again, 999.610357. Okay. Minus what I have the real number. No, it's not 51, it's 57, right? 5713. So I got 0.039057. Let's say it's 0.039, which is less accuracy than the first scan, but still it does meet the requirement. Okay, now let's do the final scan, which is the Z. Okay, now scan number 3. Let me hold on. So I don't really want to fall off, so I need to recalibrate it. So let's just do it this way. Okay, so same thing. Wait, how did I? Oh, okay, yep, same thing. 0.15 millimeters, and let's go. Okay, careful. Okay, same process. And that's number 3. All right, number 3. Feature, sphere. Oh, oops. Wait. Huh? Now how do I cancel it? Ah. Alright, not very familiar with this software, alright? I'm just not smart enough to use it. I think I triggered some bug. I always meet this when I try to just cancel it, and I found out I have nowhere to return to. Well, anyway, again, sphere 1, apply, got it, next. Sphere number 2, apply. Okay, so analysis, get it, 1, and get it to number 2. Okay, I got 999.521509. Okay, again, calculator. 999.521509 minus 999.5713. Double check. Is the correct number? Yes. Okay, so I got 0.049791, which is about to 0.05. Still meets the requirement, so I don't think there's a need we calculate an average of the 3 because, I mean, all 3 does meet the requirement. Well, another thing is you see how I struggle with the geometric wrap. It's a great software. It's just my problem. I don't know how to use it, not familiar, and very hard for me to learn how to use it, basically. But is there a software that is so easy to use, very user-friendly, and more importantly, doesn't cost that much? Let me introduce you this, the Revomeasure. That only costs you $499 per year for a subscription and more. If you backed the Trackit on Kickstarter, you get 1 year free license. It's gonna be ready as soon as we ship out the Trackit. Let me just quickly run you through the UI of it. It's still under development, but let me just quickly run you through all the functions here. You can do the GD&T. Okay, hope you like this video. Bye-bye.